Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad UWAIS bin AZMAN and my matrix number is MA22037. And today I'm gonna explain my part, which is Introduction to the Free Fall Experiment. Firstly, we must know what is free fall. Free fall is the movement of an object or body only under the influence of gravity. Free fall experiment is also known as acceleration due to the gravity. Okay, so in this free fall experiment, it's designed to demonstrate the effect of gravity on object in free fall and conservation of energy in such a scenario. And the free fall experiment is a great way to explore the principle of gravity, acceleration, and the conservation of energy. From this experiment, we can calculate the value of the time, the value of the gravity of acceleration, and the conservation of energy. So later on, we're going to see our friend discuss about the result and the formula that we're using in this experiment. Next, we got an example of the free fall in our life. Which is individuals who take part in activity of skydiving, apples and oranges tumbling from the branches overhead, a rock that comes floating down slope, and spacecraft that continues to circle around in this trajectory. So this is the example of the free fall.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin NORIZAN, MH 18015. So I'm in charge for the apparatus. So our team using just ruler, 1 meter ruler, and one ping pong ball. So we using that because a ping pong ball is a lightweight spherical object with a smooth uniform surface property, is low mass and symmetrical shape, minimize air resistance, making it suitable for studying free fall under near ideal conditions. For the 1 meter ruler is a rigid measuring instrument marked in millimeters and centimeters, providing accurate measurement of height. The ruler serves as a scale to determine the vertical displacement of the ball during free fall. So for the purpose of apparatus, the simplicity of the apparatus is ideal for demonstrating the fundamental principle of free fall and gravitational acceleration. The combination of the ball and ruler allow measurement of the drop, height, and observation of the ball motion under gravity, facilitating the data collection for the time and the distance calculation. So for the key measurement in the experiment, we're using height, which is h, the distance from the release point to the ground or bottom of the ruler. Time of the fall, which is t. If the timing equipment is unavailable, theoretical calculation can be used to estimate fall time using kinematic equation. That's all.
Assalamualaikum and hi, my name is Muhammad RAHIMI bin MOHAMAD. My ID MH19035. My part is procedure. First, we need to set up our experiment before we begin. Second, take a long ruler at the wall and make sure the 0mm start from the floor. And then using ruler, it can measure the height of ping pong ball, which are 100mm, 80mm and 60mm. And then open stopwatch from the smartphone, so can begin experiment start from 100mm.
1, 2, 3.
Take the reading of the time when ping pong ball touch the floor. And next, repeat the step experiment for 3 times for 1 point until 60mm.
Boleh. Okay, 1, 2, 3.
And then, when done taking all reading for 3 times for each point, calculate the average value of the reading. safety or precaution steps before doing the experiment and while doing the experiment. First, you need to make sure timer has reset before the start the experiment to avoid non-accurate reading. Second, make sure timer starts simultaneously with ping pong ball drop to get accurate reading, and also stop timer when ping pong ball touch the floor. Next is make sure the ball drop at the point with perpendicular. That's all from me, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. This is my part. My name is Muhammad HAZIEM bin OTHMAN, MA20172. I'm going to present the parts for the theoretical part. Okay, for the free fall laboratory experiment 7. Okay, first of all, we'll start with the introductions. So the very objective of this experiment is to analyze the motion of an object in free fall. I mean, how does the time relate to the distance of the fallen? What role does gravity play in free fall? That what is relevant to it? For the fundamental of the physics in this experiment. This kind of experiment will help us to validate the laws of the motion, those kind of things. So starting with the historical background, first we have Isaac Newton at late 17th century. He invents or introduced the laws of motion and the universal gravitation, and he did actually mathematically explains the gravity's role. Like he does the calculations, the mathematics, the numbers. And what is interesting before that, the Galileo Galilei, the one that demonstrate the object fall at same rates, and it actually laid the foundation for free fall study. It is the very beginning on the free fall study, and then Isaac Newton come in the late of the same centuries, introducing it mathematically, like that. So next is for the theoretical basics. For the force in the free fall, F is equal to force. So the formula we will have been using is F equal to ma, where F is m times g. G is the gravitational accelerations, and the m is the mass of the ping pong itself, for the balls, the object we use. Okay, and the other experiments we use to calculate which is d. This is equal to 1 over 2 gt squared. D is equal to the distance fallen. The g is the gravitational acceleration, and the t is the time. For the kinematic equation that we use in this experiment to calculate, first distance is the, I just mentioned it before, d. The v, average velocity, we divide the distance before with time, then we will have the average velocity. And as for the accelerations, the v first, like v2 minus v1, we divide by time, then we will have the accelerations. So for the analysis, we will have to calculate the time of the fallen, distance fallen, gravitational acceleration, while we assume that the air resistance is being neglected. Both of air resistance and the acceleration due to the gravity is negligible, meaning the gravitational acceleration is always the same, constant. So for the conclusions, we will validate the relationship between the distance formula. I repeat, d equal to 1 over 2 gt squared, and we confirm the gravitational accelerations. So thank you. That is all from me. We moving to the next person.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRUL bin JAHARUDDIN, MA20056, and I will present about the conclusion of free fall test. So, the key observation here is objects in free fall accelerate uniformly, then motion follow predictable patterns, displacement versus time, and velocity versus time, which is linear trend, and acceleration due to gravity calculated as g equal to 9.8 meter per second square. Next, there is source of error in this free fall test, which is number 1 is air resistant effect. Number 2 is measurement inaccuracy. That's why our team make it 3 times, and precision of instruments. So the improvement that we discussed to make our experiment better is use high-speed camera for more accurate timing, conduct experiment in vacuum to eliminate air resistance, and employ automated measuring tools for better precision. So lastly, the conclusion. The experiments confirm that free fall motion is governed by constant due to gravity. Through our observation, we found that the object's velocity increased linearly over time, and its displacement follows a parabolic trend. This pattern aligns perfectly with the equation of motion under constant acceleration, confirming that gravity acts as a consistent force pulling the object downward. This behavior highlights that the acceleration due to gravity is constant and unaffected by the mass or shape of the object, assuming minimal air resistance. Second, results are consistent with Newtonian mechanics and Galileo principles. Our results strongly support Galileo early works, which propose that in the absence of air resistance, all objects falls at the same time, at the same rate regardless of their mass. Additionally, the experiment aligned with Newton's law of motion, particularly the second law, F equal to ma, which explains how gravity exerts and force resulting in constant acceleration. This connection not only validates our finding but also showcases the enduring accuracy of this foundational scientific principle. And lastly, demonstrate the predictable nature of gravitational effect on objects. This experiment provides practical evidence of how gravity behaves predictably in everyday situations. The calculated value of g remain consistent throughout the trials, proving that gravity is a reliable force that can be mathematically modeled. Understanding the predictability has real-world applications such as in engineering, space exploration, and even sports science, where precise calculation of motion are essential. So that's all from me, and thank you.